there we go. Now I'm unmuted. Amazing. I basically just said hello and welcome. So if you want to leave some comments, then I can let you know. I can see whether everything is okay and you can hear what I'm saying. I think I'm experiencing some kind of delay, so this is going to be interesting. I've never done a live stream straight to YouTube before. So bear with me as I figure this out too. Hello, I can see some of you commenting now. This is so cool. This is so much fun. So today I'm basically just going to, once I've ironed out these problems, just try and do some learning live with you guys. Don't know how many people are going to be joining. Hopefully not too many because I am pretty shy. But do you know, I think the thing is, recording videos for YouTube is like completely in my control. Like I can edit it, I can make myself sound like good or however I want to. But when I'm doing it live, there's no hiding, which is exactly why I'm doing this, because I want to increase my confidence this year. Oh my gosh, Happy New Year, everyone. How was everyone's New Year and holiday season if you celebrate? Let me know. And also, I was thinking earlier, I wonder where everyone is, because I am currently in the UK and it is 4:30. So, nope, 3:30. Can't read. What time is it for you guys? I think there is a bit of a delay. So, loves your Merkle airdrop course on Updraft. Oh, thank you so much. That's amazing to hear. I actually love receiving feedback, both good and bad, because it just makes it all better for next time. And there is some new content coming soon. So if you guys have been looking at the Cyfrin Updraft Twitter channel, then you might have a little sneak peek as to what is coming very, very soon. I can't be sure exactly when, but soon, very soon. Like, you won't have to wait long, I promise. And I think it's going to be a good one. I'm very excited to see what you guys think, because you all seem to really like the Merkle airdrop one and learning all about signatures. So we'll see. But yeah, so 4:30 p.m. Oh, you're only an hour ahead. What was I saying? Yeah, so in this, I'm going to try. Can you hear the background music, by the way? I did have like a little chill lo-fi beats on. But yeah, let me know if you can hear that. I can try and turn it up a bit, but we'll see. I also should let one of the people on my team know that I've gone live. Ah, well, I'm sure they'll figure it out. I could probably let one of them know in a minute. What else was I going to say? Oh yeah, today I'm going to try and do a bit of Noir. And then if I get stuck / sick of that and we can't figure out too much more and I need to watch YouTube videos, then I'm probably going to switch over to doing a bit of ZK math. I'm going to try and do at least an hour because I need to leave to catch a train around 5 p.m. So we shall see how much I have time for. But there's a specific thing that I want to try and build as my first project in Noir. I've done some very rudimentary proofs before, like prove that x plus y equals to 2 or whatever, but nothing crazier than that. So we shall see how that goes. Had a doubt regarding your signature, shared on Discord and DM'd you as well. That'd be really helpful if you could check out. Shared on Discord. Okay, I don't look very much on the Cyfrin and Updraft Discords. I think mainly that's Travis DM'd me. I have my Discord DMs blocked, so I wouldn't see that because obviously otherwise it's like a lot of different requests. So I will ask Travis about that because then he can forward on your request or your question. And yeah, he can help me get the right answer to you. Sorry about that. Sorry that you haven't had your question answered, but we will get to it as soon as possible. I'm just going to wait to see if anyone has any questions. I can see, so I'm like watching myself on my live stream to like check that there's no problems. But I can see that there is quite a delay, which is interesting. I don't know. This is very new to me too. So we'll see how this goes. It's 4:30 p.m. in Poland. What I'm going to do is actually I'm going to start doing my little chill, learn and work with me session. Like I'm pretty much new to this as well. So we'll see how this goes. But you're just going to be learning with me. I'm not going to be teaching anything today. I don't think. So you're just going to be figuring stuff out with me. And also I should write myself a reminder not to swear because I am live. Because otherwise, you know, habit, I am probably going to. So I'm going to write that down right now to remind myself. Hopefully these live streams will get cleaner as we go on. We'll see. We'll see. Right, I've got that propped up next to my monitor now. Oh, okay. No, it's fallen over. That's not a good idea. Right, I am just going to tell Travis that I'm live. BT dubs. I am live. Okay, so just to reiterate, this is going to be super chill, learn with me. So I'm going to switch over to my monitor now so that we can get doing some learning. Okay, hopefully you can all see my screen and also see me still. Hello. No, I do want my Google. Okie dokes. No, just reading a comment, sorry. Sorry for posting it here, this is really bugging my mind. Yeah, absolutely. Nothing worse than feeling like you're blocked. Do not apologize at all. I just want to be able to sort it right now and I can't. So I will get to you as soon as we possibly can. So apologies for that. Okay, next. All right, let's go to Noir. Noir, maybe it's Noir language. Oops. You'll see my spelling is actually atrocious. I leave some of the spelling errors in my videos just because I don't think that's the right Noir. It's the Aztec Noir. Right, okay. Universal language of zero knowledge, get started. Yeah, perfect. Read the docs. Oh no, it was the right Noir. Okay, all right. Well, I didn't recognize the logo. Awesome. Have any of you got a nice little snack or drink with you before we properly start? I've got a coffee, a decaf coffee actually. So I'm gonna read through these docs. You can read through them with me or like do whatever else work you've got on. We can just like chill together. You can ask some questions or answer my questions if I have questions and you know the answer, but I'm just gonna read through and then try and summarize. I haven't touched this in like 4 months because I was doing the other sneaky project. So, and it's only 4 of you right now. So I feel like we're just chilling together, which is really good fun. So I'm just going to read through this. I'm a really slow reader, by the way, just to let you know. Noir is just sick. And their team are really nice, by the way. You should check out the Aztec team if you haven't already. Who of you guys know what a ZKP is? Like a zero knowledge proof? Or is this all completely new to you guys? Okay, absolute basics. To be honest, me too. I've done some of the math, like the prerequisite stuff, like a bit of the videos I posted. I don't know if you've seen them, but plus group theory and what a field is, plus a bit of elliptic curve math. Like I will have a video coming soon on elliptic curves and elliptic curve pairings. That is where I stopped because then got sucked into this other project. So Noir is essentially it's a domain specific language. So it's specific for writing proofs. So I want to prove that I know some number that satisfies some condition to you without revealing what that number is. That's essentially what a mathematical zero knowledge proof is. The example that most people like to use is, where's Wally? And they're like, prove that you know where Wally is without revealing where Wally is. And you can do things like take a piece of paper that's bigger than the picture, cut out a hole, and then align Wally. Actually, I think in other countries it's Waldo, but with the hole, and then you can see where Wally is, or Waldo, without revealing his location, because you still wouldn't know where in the picture he was. And there's other ways of doing it, and there's lots of different examples like that. And Noir enables you to write your conditions. So I need to make sure that one input squared plus another input is equal to 10 or something like that, or prove that or require that the age input is greater than 18 or greater than or equal to 18. Anything that you can define mathematically, you can have as a rule, and these rules are known as circuits, or what's the other word I'm looking for? Constraints. There we go. Constraints. So a set of constraints is known as a circuit, and they are specific rules that the inputs need to sort of confine to. They need to satisfy those rules. And that's kind of like the skinny as far as I understand it at the moment. So it says it here, ZK programs are programs that can generate short proofs of statements without revealing all inputs of the statements. So basically, you don't actually need to understand how ZK proofs work or how ZK proofs are verified before you write Noir programs. All you need to know is how to write the constraints and write them in a way that is secure and not buggy. And there's these things called soundness and completeness, which when you're auditing ZK protocols, you're looking for violations of these two things. And as long as you can write those circuits, you're pretty much good to go, because the proofs are generated for you and the verification is generated for you as well. And actually, Noir's pretty cool, as well as Circom. So, that's the other thing. If you heard of Circom, it's kind of interchangeable with Noir. Noir, in my opinion, so far is cooler. I think that's mainly because it's not... Circom is... How do I explain this? It's written such that it's highly compatible with Hard Hat. Like, all of the plugins and stuff are Hard Hat. And I'm not a big Hard Hat fan. Like, I don't really use JavaScript at all since, I don't know, the last few years. Are we following any specific path, like going topic-wise or exploring random things? Yeah, good question. Today we are just exploring random things. I am just chilling with you guys and going through the Noir documentation, and I'm going to try and build something. We'll see how I get on, because this is my first live stream and it's currently already 10 to 4 my time. I need to leave here at 5. So we've got about an hour. I'm probably just going to go through the Noir documentation and refresh things in my mind. And this is just going to be like a chill, work with me, study with me. You guys can like do your work while you watch and like have it on in the background. But this is... Can you hear the focus music, by the way? Let me know. Let me know if it's annoying as well. But yeah, I just thought it would be fun because I always have YouTube videos on in the background of people like doing vlogs, or sometimes I put Pat's live streams on in the background and like kind of work with him. And then I was just kind of explaining the basics of what a ZK proof is. What's the difference between a zero knowledge proof and a regular public key verify signature? I don't really know what your question is. A zero knowledge proof is like another cryptographic method. Like public private key cryptography is like a different avenue completely. That's like encryption and decryption of data so that other people can't like understand the encrypted data, whereas zero knowledge proofs is like a way of proving knowledge of something without revealing it. Like no parties can decrypt this data. It's not necessarily, I mean, there's arguments about like the fact that it kind of is encrypted using elliptic curves as well, but it's also like it's not really technically encrypted. There's a whole debate about whether you can call it encryption or not. That's not a very good answer. I feel like I am too new to this to give you like a super succinct answer. I'm definitely not a pro at this yet. ChatGPT and in particular Claude are very good at answering those kind of questions. So I do recommend that you watch that. Why don't we make some path for maths? Because I also started studying math. It will help me as well, vice versa. Yes, definitely. I am currently in the middle of making a math course. Not course, like, right, hang on a second. Let me take that back. I'm not making a course necessarily. I'm making some videos on YouTube for the ZK math. I've got one coming out next week on group theory, and I'm going to be going through it step by step there. Here, I want to try and do something more practical today with Noir, which doesn't require the math. I am going to be going through the math as well on my YouTube channel. I'm like writing out and making it all like fun and stuff like that on my iPad. But at the moment, today, I'm not going to be going through the math because I am at a certain point with the math, which I would rather do it in videos so that I can like continue my learning from that point rather than like going back on the stuff which I've already made videos I've got yet to post. That's a really convoluted explanation. Anyway, I'm going to get started because oh my God, you're the one who asked. Yeah, that was really good timing, by the way, because I literally was recording the video that morning. It was very funny. Me and my partner were laughing about it. We were like, this guy knows. He knows what's happening. Anyway, so going to continue now. I was reading through the Noir documentation. I'm not going to be talking this whole time, by the way, because otherwise I'll like lose my voice. So just to reiterate, this is a chill study with me. You can like do your own studies or whatever. If you have any more math path, please share. The ZK book is pretty good. ZK Moon Math Manual is also incredibly good. I have been using the Moon Math Manual and then whenever, oh, and also Vitalik's blogs. They are chef's kiss, fantastic. Cyfrin will be coming out with some math articles to complement the videos soon, but I don't know what the release schedule for that is right now. But I will be sharing everything on Twitter as and when it comes out. So, the other cool thing that I found out about Noir is that because it goes to ACIR, it means that you can compile it for different, or like, does it mean compile? Yeah, compile it into different proving backends, which means that you can create like Plonk-based ones or R1CS proofs, like Groth16, that kind of thing. I think their default is called Barattenberg. Yeah, here, Barattenberg. And I think Barattenberg is Groth16 based, but I don't remember. Yeah, I mean, we'll find out. Oh, yeah, they've said what I said earlier, requiring no knowledge of understanding of the underlying maths or cryptography, which is super cool. The other cool thing is that you can generate a solidity verifier, like automatically. So you could verify your proofs on chain, which I think is so cool. The only thing I don't know is how you like integrate that into tests then. Like how would I test my verify? I guess I'd test the proof with Noir which is Rust based. And then, I don't know. Do we call it a contract or a program? Don't know. Storage and execution of private information. Woohoo. Okay, they do call it an Aztec contract. Awesome Noir repo is a collection of libraries developed by the Noir community. Okay, cool, because I was thinking about what if we needed hash functions. How would that work? Oh, someone had a hash function question earlier. Oh, SecP 256K1 reveals the public key as the proof. Does it not reveal? It's nothing to do with public and private keys. It's kind of like completely different. Oh, sick. If you want to help with Cyfrin, then like jump in the Discord and let them know, because I think we have had some people do freelance articles. In terms of the ZK math ones, this is a personal like passion project. But in terms of other articles, I know that they are doing some other articles at the moment. So if you wanted to help out with that, then I'm sure they would be keen to trial you. I don't know, but I would chuck that in the Discord and let them know that you're keen to write. I'm getting really distracted by the chat and not actually doing anything. Right, this is supposed to be for all my productivity. Not that you shouldn't ask questions, just to reiterate. Keep asking the questions. Okay, there's a section on dependencies. Let's do the getting started. So I have done all of the installation stuff before, so I am actually not going to do that, but I'm going to quickly go through it. Nargo. Oh yeah, I forgot they had Noir up, which is pretty cool. I swear everything has an up. Foundry up. They should make a ZK sync up. A sync up. Sorry, you guys are going to see how annoying I actually am. I normally have to cut all of this stuff out when I edit my videos. So this is one of the things that boggled my noggle for honestly ages, is the fact that you have a ZK front end and a ZK back end. And I was like, what does that even mean? Essentially, the front end is like the circuit writing part, where you define all of the rules that your inputs need to satisfy. And I think the witness, which is like your inputs, is part of that front end. But then the back end is where the proof is generated and verified, or like the verifier code is generated, something like that. I actually can't remember because, like I said, it's been a good few months. But we'll see. Oh, it literally says it right below. I keep doing this. Proving backends provide you the abilities to generate proofs, verify proofs, and generate smart contracts. This is those verifier smart contracts that you can deploy on chain, which is really cool because the proofs and the verifier itself are generated off chain, and then the proof can be verified on chain through a smart contract, a verifier smart contract. For instance, like with rollups, a witness is usually a signature, I'm pretty sure. So that's not quite correct. The witness is your inputs that you want. You're saying, I know the solution to this problem. They are your proposed solution. This is separate from signatures. Signatures is like a different cryptographic algorithm, concept, that's probably the right word. ZKPs are like completely separate from that. This is making me notice how much I say the word like. Now I'm going to get stuck in a recursive like loop. So let's say for instance, it's probably better with an example. Let's say I have the circuit or condition or constraint that I want x plus y to be equal to 5. Then my inputs are x and y, and my witness could be like 3 and 2, for instance. No, so that it's just completely separate to signatures. It's nothing to do with signatures. The provider of the signature is not. It's not like there is no signature. You have like the witness is those inputs, and then those inputs are then encrypted. Well, they're converted into elliptic curve points, and loads of other funky stuff happens. I'm pretty sure there's a definition somewhere in here of the witness. I wrote one somewhere, but it hasn't been published yet. Reference. It's not going to be in debugger. Tooling. How-to guides. Noir language. Concepts. There we go. Witness is not there. Okay, let me just look up on my article. Yeah, so the witness is like a private input. You can also have public inputs as well. I think when we do like an example, this is going to become... Oh, okay. I'm seeing the confusion now. So this person said, quite the contrary. That's a great name. I'm confusing it with how Bitcoin segregates witness works, I guess. I honestly know pretty much nothing about how Bitcoin works, but this sounds like a Bitcoin specific thing where they are overloading, or ZKPs are overloading the use of the word witness. It sounds like this is completely separate from that kind of witness, hence the confusion. So we cleared it up. Amazing. I'm going to go back to that get started. So this is where you like install that proving backend, this Barrettenberg. I think they've got a repo for it, which explains it. And it's really cool because you can just use this BB command. I have done a very simple one before. And it was really easy to use. So yeah, if you want to do the installation, then go ahead. I have done this before, so I'm actually not going to be doing it right now. Nargo provides the ability to initiate and execute Noir programs. To be honest, their terminology was sometimes a little bit confusing. I'm like, what do you mean initiate and execute? I feel like they should define those words and have a little glossary. Okay, so this prover.toml file, or our input values will be specified. So the witness in this instance, they're saying it's like the encrypted inputs. Okay, I'm gonna open up my simple example. I think I've got one in here. Minimal Noir. Okay. Let's go in there and open it up in my code editor. Okay, so I made this minimum age program, or I think they call it a contract, but I don't know if I like that because contracts for me are on chain. Main.nr, this .nr is like, it's a Noir file. I don't know if there's any extensions. I need to look into that to make this pretty and colourful. But then you have the test file and then the actual function. Sorry, the test function and then the actual function. So I've got this minimum age variable, which is of type uint8. So unsigned integer 8 bytes, bits, bytes. I'm really not very good at bits and bytes. Equals 18. So that's my minimum age. And then we create an assertion. It kind of feels like fuzz testing. I don't know if anyone else feels that vibe too, but like basically I'm saying check that the age provided as the witness is more than or equal to this minimum age that I've defined. And then in this test, I'm running that function with 18 and checking that it passes. And then this will fail. So if I uncomment that, then the test should fail. So this is a nice simple example. The one thing that I got caught up on was I was like, okay, sure, but like I can just input 18 and be like, yeah, I'm 18. Like how do you get the actual age from someone? And then I was like, oh, you get like a passport and then you scan it. And then I was like, oh wait, hang on, now we're introducing like governments and intermediaries. And I was like, oh, okay, this is like the Oracle problem. So that was good, that was fun. Anyway, and then I'll go top more. So where was the other stuff generated? Okay, let's see if we can actually run it. Oh, yeah, I copied Patrick and made like a little thing when my terminal starts up. Make to it today better than yesterday. I think his is like, I can't even remember, I'll be honest. So the first thing we needed to do was run new, which we've already done. Oh no, maybe we haven't. Yeah, we have, because we have these two files. Compiling and execute. We can now use Nargo to generate a prover.toml file. Oh, cd hello world, Nargo check. See if I can just run Nargo check. I bet it's gonna not work. Cannot find nargo.toml. Oh, I need to go inside circuits. CD circuits. Nargo check. Oh, right. This needs to be a U8. Okay, cool. So now we've got this prover.toml file where we can put in an input, I guess. So let's say 18. So this would be got from some front end where they're like verifying that your birthday is got from a reputable place. I don't know. Patrick's here. Oh my god. Hey, love your content. But how do I become a smart contract dev? You know what, Patrick? You're just gonna have to try harder, to be honest. The best way to become a smart contract dev is to lift really heavy. And to be honest, you just haven't got it yet. Keep going. Okay, where was I? Before I got distracted. So, oh yeah, so we're in the prover.toml file. So I don't really understand what the difference is between the prover.toml file versus a witness. Lift heavy. Yeah, no, heavier. No problem. We can now use Nargo to generate a prover.toml file. Yeah, but I want to know what that is. Okay, project breakdown. Let's see if that tells me. It is specifying the input values for executing and proving the program. So, but is that the witness? Why don't they define what witness is in here? Supply the inputs to the Noir program, both private and public. Yeah, I saw this before when I was doing this like 4 months ago. Still don't really understand why you'd have some private and some public. I guess because some of the data will be private and some like want to be ZKified and some of the data will want to be public. Don't know. We shall see. When the command nargo execute is executed, after we put these inputs in, I guess, nargo will execute the Noir program with this using the input specified in prover.toml. Aborting if it does not satisfy the constraints, but then what's the point in doing the verification? This is what boggled my noggin before, and I got stuck in a bit of a hole with it. But okay, so execute is like checking that these inputs satisfy your circuit. So in my example, check that this age in the prover.toml file satisfies this circuit. So I can run, what was it? Nargo check, nargo execute. Let's go back to the quick start. And it will generate the witness. Okay, but like you're already doing the check of ZK. I don't know. Let's just try it. Okay. God, punching everything. Now go execute. Circuit witness successfully solved. Okay. Target circuits.json. Ooh, this is cool. Looks like a little ABI. Let's format that document. Oh my god, it is an ABI. That's cool. Ooh. So the inputs are name. Oh, yeah, right. The name of the input is age. Type, it's an integer, which is unsigned. The width of 8. Visibility private. I think to do it public, you like say pub in here or something. I can't remember. Target. Why haven't I got that then? What? Oh, because I haven't done the execute bit yet. Oh no, I did do that. The witness corresponding to this execution will be written to the file .target/witness-name.gz. I don't have that. Yeah, so I think I agree with what this quite the contrary is saying. I think they mean that our output is the witness, which is then provided as verification to the next condition, like a returned bool value. Output is the witness. What do you mean the next condition? Because we're kind of like, that's it with the conditions. Because now what we could do is generate a verifier smart contract, which would take the proof and verify it. Like all of this BB prove stuff. But I don't know. Yeah, this is definitely true. So if the witness is true, do something else, don't do thing. Yeah, definitely. But like, what's the point in verifying it if you can't even create the witness unless it's true? Like, what I don't understand is like, how does Jim, some random guy, not the Jim, come in and be like, oh, I want to prove that I have some money in Tornado Cash and I want to get it out. Here's my proof. How do they generate that proof if they don't? Like, this system is set up so that surely that Jim can come along and generate his own proof. But like, then they need the program. I don't know. The setup is kind of confusing to me. And this is like where I keep getting confused. Generate the witness that we need to feed to our proving backend. Yeah, I get that bit. But why does it need to be a valid witness? Why can't it be a false one so that the proving backend could be like, yeah, nah, that doesn't satisfy it? I guess because someone could come in and tamper it. Maybe we'll understand more if we keep going. I'm really confused why I don't have that .gz file. GZ, if you're American. Got it automatically. You can pass your person. Yeah, so I have that, but I'm gonna run execute again. Let's see what happens. No. Oh, because I didn't have a witness file, did I? Oh wait, no, it's in here. Right, let's go through it again. So what do we need to do? Oh yeah, here we go. That's the pub. That makes it public. Now go to generate a proof.toml file where inputs will be specified. Did that. We did Nargo check, didn't we? Yeah, we did. The witness cross. I did spell it right? Yeah. The live will be saved? I think so. If not, I can unlist it. Relist it? Relist it. I think it will. I think by default it does. GN. Oh, thank you so much for joining. Okay, I'm gonna just try this, but I'm gonna have different names for the things. .search target / helloworld.json, but I don't have this .gz file. Maybe I'm in the wrong place. Right, let's just do a little / and then run it again. Wait, did that do something? No. cd / why am I? Okay. Then run it again. No. This is so weird. What if I just change this to like something false? Does it revert correctly? Yes, failed constraint. Okay, so that works. It is looking in here at least. I just don't know why I'm not getting that other file. Maybe I need to update stuff. Maybe I need to do this Noir up. Let's do a Noir up. Yay! If in doubt, do a Foundry up, do a Noir up, and all will be well. Okay, so that worked. So now we can continue. We're no longer blocked. Woohoo! Where were we? We've got down to here. So automatically compile your Noir program if it wasn't already and was edited. You may notice it in helloworld.json, which ours would be circuits.json. Yeah. It uses the name, by the way, I noticed, of this folder. So like this is your project, and then whatever uses your project name will be your witness file name and your artifacts file name. Then we use the proving backend, and this is where the proof is generated, the verifier code is generated, and how you generate a verifier smart contract, which is cool. So we can do bb prove -b, which I can't remember what that is now. Anyway, this will be the same, except we'll have circuits there, -w, that's -witness for the witness file, and then the output is here. So let's just copy that and then edit it. We can keep that as proof, that's fine. This is going to be, oh, what was that again? Just delete the whole thing. ./target /circuits.gz, and then this needs to be circuits as well. Unknown variant index for enum. Now maybe I need to do that BB up or something. Because I haven't used BB in a while. Let's have a look at BB. Because I haven't used it in like 4 months. Do they have a BB up? I think it's just a curl command. Oh yeah, BB up. Let's just run it, see what happens. BB up dash dash. Version. Okay, I don't know what's wrong with that. Maybe I just need to install it again. List of proving backends compatible with Noir. Oh my god, what is that? Okay, that's to install Barachtenberg. That feels sketch. I'm not going to do that again because I haven't done containers. Oh. Installation. Okay. To install the Barachtenberg version compatible with the current installed Noir version, run BB up. So maybe I do need to do this curl command again. Always check what the scripts do. Oh, this is nice. Oh, that makes me so happy. Let's check where that takes us. Copy that bad boy. Right, so nice little bash script. Install BB up. The URL is that, which looks correct. Okay, that looks fine to me. Definitely use dev containers. I'm gonna pull that over there. Okay, and then I'm gonna use BB up. Okay. It's got a new version now. We've installed Barachtenberg. Cool. So now we can go back to the getting started. We can run that command again. Wow, that's so cool. Redundant call to finalize circuit. Is this intentional? I don't know. I don't know what that means. Minimum circuit size 0. Non-filled gates 53. No idea what that means. Yeah, minimum circuit size 0. Non-filled gates 53. No idea what that means. But we've now got this proof file. Whoa, that's funky. I wish they explained this a bit more in the documentation. Naming can be confusing, especially when you pass them to the BB commands. If unsure, it won't hurt to delete the target folder and start anew to make sure you're using the most recent versions of compiled circuit witness. Okay. The proof is now generated in the target folder. Yeah, it is. To verify it, we first need to compute the verification key from the compiled circuit. Oh my god, I forgot about this stuff. That was horrible. My coffee is now stone cold. Sorry, I just needed to sort something with a friend. Okay, so now we can do BB write verification key. So we need to generate a verification key. Again, I wish I knew why you had to do that. Notice that in order to verify a proof, the verifier knows nothing but the circuit. Yes, which is compiled and used to generate the verification key. Obviously, how condescending. Okay, let's just run that. And we're gonna need the output we can have as VK, that's fine, and this needs to be circuits. I don't know why I keep getting this warning. No idea. And then let's do the verify, because then we can see if our circuit has worked correctly or not. And oh, I remember this from before. It's really nice because they give you nothing if it works fine. If it doesn't work fine, then you'll have an error. So lack of information is a good thing. Okay, let's continue. I want to understand more like what we've actually done. Notice that in order to verify a proof, the verifier knows the circuit, which is quite. Oh no, we've read that bit. For the public inputs, you may have noticed that they haven't been specified. This behavior varies based on each particular backend. Oh, that's cool. Oh my god, that's so cool. So if you have any public inputs, i.e. like just public known information, then what does this head do? If your public inputs are 32 bytes, again, I really don't understand why they're not explaining this command. Head-c 32 for 32 bytes. Proof od /an-v-t x1. So that was that public one, which was x. tr-d. What? I don't understand that. Congratulations, you now created and verified a proof. Your very first Noir program. Woohoo! I have, but I don't really understand what happens. Let's go to the next step to see project breakdown to see what actually happened. Okay. Maybe you asked ChatGPT regarding the head-c command. Yeah, I was thinking that. And then I was like, I don't think I'm signed into ChatGPT on here. So, and then I got lazy, so I think that's actually a good idea. Let's do it. Let's just try ChatGPT because I don't really want to log in, to be honest. What does... Good idea, by the way. Thank you. This command mean. I am running through... Ooh. Okay, so it's reading the ./target/proof file. Output the first 32 bytes of the file. Aha. And this is the file path. Octal dump command, which displays the content. Hey! Welcome, welcome. We are just chilling and working together. I'm currently working through the Noir documentation. Feel free to do whatever work you would like. If you just want to chill with us, then feel free. Currently, I'm just going through what this command means. This is an octal dump command which displays the contents of a file in various formats. Okay, just get the raw data, an-v, this forces the output. This is od to output all the data, even if it's repeating. Display the data in hexadecimal format with 1 byte per value. Okay, right. So basically get the first 32 bytes, clean it, and show me everything in hexadecimal. Okay, but I don't think we don't have any public, where are we? I've got too many tabs already. We don't have any public inputs, so we don't need to do this. But what I don't understand is, like, how am I specifying the public input? Oh no, this is just about seeing the public input. Oh, okay, so when do I specify what it is though? Oh, I specify, right, okay. This makes sense. So in the prover.toml file, you would specify the public input as well. But this is if you want to read the public input, you run this command. Okay, we're fine. So we don't actually need to do this because we didn't have public inputs. If we wanted to, and we did, and we were a verifier, and we wanted to see what the public inputs were, that's what we do. Cool. Let's go back to the project breakdown. Yeah, we didn't run this because I already had the project going. Now go new. Sorry, just seen a question. I'm gonna answer it. I finished all your training videos with Patrick. What should I do next? Build something. Just build anything. I built my first project when I barely knew Solidity, and that's how I got my first job. And it didn't work. It didn't have any tests, and it certainly wasn't finished. But the people who I actually did it as a hackathon. And Patrick was actually judging that. No, was he judging it? I don't know if he was judging that one. Maybe. He definitely announced the results. But anyway, point was, because I'd done something new and I built something, tried to build something with my newly obtained knowledge, they were like, that's sick. So just build something. Would be my best advice. You don't need to get stuck in tutorial. I was gonna say tutorial hell, but I back ourselves that we make pretty good tutorials, so they're not really hell. But just don't get stuck with the tutorials. Like, just try and build something. You are so welcome. Thank you so much for being here and supporting us. Okay, so we've got the source, prover.toml, nago.toml. Cool, but you haven't really told me what they are. The source directory src holds the source code for your Noir program. Yeah, makes sense. By default, only one main.nr file will be generated within it. Okay, cool. Can I have multiple? Don't know. What happens if I have multiple? Don't know. Need to try it. Prover.toml is used for specifying the input values for executing and proving the program. You can specify toml files with different names. Okay, cool. So you could have lots of prover files. Oh, that's cool. With different names, like different people, for instance. That's so cool. Okay. GN, thanks for coming. Nago.toml contains the environmental options for your project. Okay, so this is like my Foundry toml. Makes sense. And then you can have workspaces. I'm not going to go into that right now. Package section. Each package section. Oh, this. I'm not gonna go through that right now because there are other more pressing things that I don't understand. Main.nr. Okay, this contains a main method. This is the main entry point of your Noir program. So this is like my circuits. The parameters x and y must be supplied by the prover. This is the person saying, I know the inputs, the witness that satisfies this circuit. Since neither x nor y is marked as public, I mean, they were in the previous example, but okay. The verifier does not supply any inputs. Oh, so the verifier would supply a public input then, that implies. Maybe I should get someone on the Aztec team to join a live and get them to explain all of my questions. The prover supplies the values for X and Y in the prover.toml file. Yeah, except if they're public, and then apparently the verifier does, but you haven't really defined to me who these people are. I kind of know from my research, but would be helpful. As for the program body, assert assures that the condition must be satisfied. This makes sense, and is constrained by the proof of the execution of said program. If the condition is not met, the verifier would reject the proof as an invalid proof. Yes. Fine. Get it. Prove.toml. This is a file in which the prover uses to supply the inputs to the Noir program, both private and public. Hang on a second. You just said that the verifier does that if it's public. Well, that's a little contradictory, isn't it? Okay. When the command nargo execute is executed, nargo will execute the Noir program. Using the input specified, aborting if it finds it does not satisfy the constraints defined by main. In the example, I must satisfy the inequality constraint if the output name is specified. Okay, fine. Yeah, we know that. This can be used to generate proof of the execution. Wow, that makes so much more sense. Okay, so the proof is proving that the execution was legitimate. I'm proving that my inputs satisfied the constraints and the execution of those inputs satisfying the constraints were proving that. So that there's like no possible someone coming in and tampering the system. Okay, cool. That makes sense. That makes sense. I love it when that happens. Array of structs. The following code shows how to pass an array of structs to an R program to generate a proof. Oh, does anyone get it where their headphones like hurt the top of their head? Mine are really hurting right now. I don't really like these headphones. They suck. Does anyone recommend any good headphones? I was thinking about getting the Apple ones, but they are extremely expensive and I need to get a standing desk more. The following code shows how to pass an array of structs to a Noir program to generate a proof. Okay, fine. An array, because it's in square brackets, of type foo with 3 elements, I guess this is saying. Take the second element of foos and get the bar element, and get the second element of foos. Sorry, and get the baz member. So this, I meant bar member, baz member. And then you have three foos elements. That makes sense. With members for each. Okay, that's cool. That's cool. I'm gonna sneeze. You can specify a TOML file with a different name. Yeah, we know that. Using the prover-name or -p flags. This command looks for proof inputs and generates a witness. So the witness. To be honest, I think they keep using that word interchangeably, because whenever I've seen it talking about ZKPs, like in the MooMath manual, it is the inputs. So I'm like, I need to get a bit more clarity on that. We'll see. Executes. Yes, we generate a witness. That makes sense. This command looks for proof inputs. Okay, so this is like the custom version. BRB, dinner time. Enjoy. Have a nice dinner. I'm hungry, so I'm very jealous. I don't know if I'll still be on when you come back, by the way. It contains a true, false value with this. Can we open up the witness? I didn't even think of that. This is the witness. Oh yeah, no, we can't. Oh, I'm gonna look it up in a second, but I'm gonna park it for now. Because I'm pretty sure it's like the encrypted inputs, depending on your ZKP method, whether it's R1CS, in which case it's elliptic curve points, or what was I going to say? What's the alternative? Plonk. Or I wonder if Noir can do Starks. That would be cool. Okay, so then this is how we do it with other ones. I mean, the value checked by the verifier is a true false value. I don't think it's as simple as a true false value. I don't think so. I think because like we're gonna generate a whole smart contract as the verifier isn't actually a person, it's a smart contract. So it takes a proof. Like, I don't know if you've taken the Merkle tree course on Updraft, but the proof is like a hash. Actually, it's an array of hashes. I feel like it's something like that. The proof is like some code that you input to the verifier. But we're going to get there. I feel like we just need to like take our time. Now you understand these concepts, you'll probably want some editor feedback. I mean, sort of. But you don't really explain any of the concepts particularly. Control flow. If else loops. Okay. So we're going to go into some syntax maybe in a minute or maybe in a different time. But I want to try and find out what it means by thinking in circuits. Okay. Let's look at these explainers. I want to create that. What I want to do is create generate as legit verify. This is what I want to do next. Noir is universal. The witness and the compiled program can be fed into a proving backend such as Barrettenberg, which we can then generate a verifier contract for deployment on blockchains. Yes, this is cool because it's going to be on chain. This allows for a powerful feature set. P2P guessing games, which is what I'm going to build. Hopefully. I'm not going to go through deploying it because I don't want to, but I am going to generate a verifier contract and then look at it. Okay, run down. One command process. I remember this. This was cool. Compiling and deploying it can have some caveats. I don't see why. Generate a contract. Ooh, Nargo compile. Is that it? That's so cool. Nargo compile. Whoa. Where? Why? How? Where? Sorry, that was so annoying. I mean, it didn't. Oh wait, we did that already. No, it's BB that we need to... Ooh, ultra honk and ultra plonk. What's that? Huh. Okay, so then we can do BB contract, right? Yes. BB contract. Whoa. Okay, contract.salt. This is so cool. Okay, now we've generated our own verifier smart contract. I've got an ultra verification key with loads of assembly. Yule. I need to finish the assembly and formal verification course this year at some point. Okay, then we've got an abstract contract with friggin' tons of constant variables. Why am I looking through it with the tiniest window possible? Do you know the amount of times I have to refilm content because I just look at it through the like, oh, weeniest, tiniest window? It's ridiculous. Okay, then we have get verification key hash. This is really awesome. And then to deploy it, we don't need any constructor params. I mean, I assume that I'm going to be using this. Okay, then we got this verify function, which is massive. I wonder if they use the... Oh my god, this is so cool. Okay. Oh my god, I don't understand anything that's happening here. But it's just cool. I am looking for something specific though. Not just scrolling aimlessly. There is an opcode for doing a pairing though, because I reckon it's probably doing some of that here somewhere. Oh! Compute arithmetic widget evaluation. Oh, it's doing a plonk. Oh, I like that they've explained the math. That's nice. I'm not going to read it right now, but it is nice. Oh my god, okay, right. Let's just continue going down. I want to get to the bottom of verify. This is massive. How is that not? Okay, then we've got the contract. Ultra verifier is base ultra verifier. Get verification key hash. Load a verification key. Okay, this is, yeah, I mean, the only function you really be using would be verify, and then it takes in your bytes proof and then the public inputs. Oh, but then why do you specify the public inputs in the proof? Do you know what I'm going to do? I'm going to do this again, but I'm going to put this as... I'm going to just get a random variable. Let's call it X. Pub. Let's make it a U8. I'm going to do nothing with it. Sorry, I'm going to yawn. I guess these won't work. Nargo compile, because I don't have inputs to them. Yeah, I don't. What's... How was I supposed to do it then? Oh, after the colon. Here. Pub. Let's go again. Yeah, expect 2 parameters. Okay, fine. Let's just do like random number 8. Why not? Unused variable. That's a warning, so that's fine. I can't remember what the next step was. Nargo execute. And that should... Accepted argument X, but none was found. Oh, wait. No, there was one before that, wasn't there? Nargo check, that's what it was. Nargo check. Dash dash overwrite to force overwrite it. Oops. Do the proof. Get the proof, and then we need to get the verification keys, and then we need to verify. Which works fine, and now we can do the getting of the contract. I mean, I think that updated. So now... So I did need to have the public input. So then why am I providing the public input here? That doesn't make any sense. Why would I provide the public input to verify and then also provide it in that prover file? And it was contrasting itself. Here we go. An array of public inputs. Okay, but what? What? Okay, I'm gonna go back here. No, I'm not gonna continue with that. Explainers. Thinking in circuits. I want them to tell me what all the terms mean in this specific context, not in like a general ZK context, but what it means. Oh my god, they have a dev container stuff. Guys, you should all learn about dev containers. I've been looking into it recently and it's very good for making sure that you're not installing dodgy stuff. I need to go in 10 minutes, so I don't want to get too much into it. Okay, I'm just going to ask ChatGPT very quickly, what is a witness in a ZK proof? To see what it tells me. Piece of information that allows a verifier to prover to convince a verifier that they know something or that a particular statement is true. So it's not the input itself, it's the information that proves that they know the thing. But how is that different from the proof? Okay, so then I'm going to write that question just in case I still have it by the end. What is the difference between a proof and a witness? Is the secret or hidden data that the prover uses to create the proof. Yeah, okay, that makes sense. So it's like you have the input and then from that you create a secret or hidden data, which is basically like the encrypted input. It is often something that proves the validity of a claim but is not directly disclosed in the proof. Statement: I know the solution to a Sudoku puzzle. Prover: the person claiming the solution. Verifier: the person trying to be convinced. The solution to the Sudoku puzzles. The actual numbers filled in the grid. Yeah, that makes sense. But then I don't really understand how that's different from the input still. What is the difference between a witness and a circuit input? Use the solution to generate a proof. Yeah, prove I know this thing. However, the proof itself would only convince the verifier that it's a valid solution without revealing the solution. The witness, the Sudoku grid, is never directly disclosed to the verifier. Yes, that makes sense. It's often an instance of the solution that satisfies the statement without being proved. For example, yeah, the set of values that satisfy those equations. So, how is that different from the input? What? Okay, in cryptographic protocols such as ZK Snarks or ZK Starks, the witness typically refers to... Do you know what? I'm seeing a lot of like people using terms and there's like no consistency. The secret data that... Private input, the secret data that proves the claim. In the case of ZK Snarks, which is what I've mostly looked at, the witness is used to generate the proof that a certain computation was done correctly. Remember, it was proof of the execution. Oh, so many words. The secret data commitment. The witness is combined with a cryptographic commitment such as hash functions or homomorphic encryption. Yeah, kind of. This is that conversion to elliptic curve points in... Actually, do you know what? I don't even think Groth 16 has commitments. It definitely doesn't. Commitments are plonk. Ooh, just switched to dark mode. Do you know what? I don't know why I wasn't in dark mode the whole time. I'm so sorry for your eyeballs. Private input, the data. Oh yeah, we've read that. Commitment. Example in ZK snarks. Yes, because plonk is a type of ZK snark. In ZK snarks, a witness might be a sequence of computations that result in a valid solution for a certain problem, such as... Oh, so it's a combination. Fun stream, thanks for sharing. You're so welcome. Thank you for joining. Come again soon. Oh, okay. I think this is making more sense. I don't know if anyone else is reading, but this is making more sense to me. Why is it called zero knowledge? I am back. What did I miss? To be honest, I don't remember. You missed... I'm going to be stopping in like 5 minutes, but because I'm stopping, I think, did you... I don't know if you were looking, but we did the verify smart contract by running BB contract. And then it's, we were looking into like what actually is a witness, because I wanted like a more distinct definition, because I don't really understand what's the difference between a proof and a witness, and then what's the difference between a witness and a circuit input. It seems like the witness helps you create a proof of the execution, and the witness is a combination of both the inputs, which are valid, so a valid solution, plus, because like the input could be invalid, but then you just wouldn't generate a witness. Yeah, it was literally just I ran BB contract, and then that generated the verifier smart contract, which you could deploy using the BB backend, Barrettenberg or whatever it was. We didn't go into too much detail. I was just like, whoa, there's loads of stuff and it's all assembly and it looks really complicated and cool. That was literally it, but we did that for ages. I got a bit like bamboozled by it. Anyway, so what was I saying? It's a combination of the valid solution to a certain problem plus the actual sequence of computations that occurred to prove that the input satisfied the constraints. And then we're just looking at this example. So the witness could be a set of values representing the inputs to a computation. In the case of a proof validating a transaction, what would it be? Include the transaction details and any necessary cryptographic commitments. Okay, I'm still going to ask it those two questions. Stay logged out. Difference between a proof and a witness. How long have I got? 4 minutes. A proof is a cryptographic object that convinces a verifier that statement is true without revealing the underlying data, the witness. Okay. In ZK proofs, the proof is typically small, succinct, hence ZK snark, and can be verified efficiently, blah, blah, blah. A proof might consist of cryptographic values like commitments, hashes, and other cryptographic objects that allow the verifier to check the validity of a statement. Yes. Proof is the object that you submit to the verifier, which contains the cryptographic values derived from the witness. So this is why I feel like you do actually need to know the math, because you're like, what do you mean an object? Whereas if you like do it from scratch yourself, then you'd know what those things mean. So I am going to continue with that. This is my commitment. Aha, I'm so punny to that. Witness. The witness is the secret information or data that proves the statement being made as true. It is the solution or hidden piece of data that the prover knows and uses to create a proof. The witness itself is never directly revealed to the verifier. It stays private. Example, in the Sudoku example, the statement, I know the solution to puzzle, the witness is the solution. Okay, but what was the proof? It's all of the maths that was generated to say, yeah, it works. Key difference, the witness is the private data to construct the proof. The proof is the cryptographic evidence. Cool, let's see it in math at some point. Difference between the witness and the circuit input. The witness is often defined as the secret data or hidden information. So it's what I said like an hour ago, I think. That satisfies the constraints of a given statement in the context of cryptographic proofs. The witness is a set of inputs that make a computation valid or true. It's usually private, and the goal is for the prover to demonstrate the input of data. The witness might include The private key used to sign the transaction. Oh, that's in case of blockchain transaction. Don't get that complicated, confused with like, oh, I thought you said it was nothing to do with private keys. Yeah, because that's in the specific example of a blockchain transaction. We're proving a blockchain transaction. It's talking about rollups. So just wanted to make sure that we didn't get confused. Sorry, that was quite aggressive. I didn't mean aggressively at all. I was just like, they're going to get confused. And we're already confused enough. I mean, I'm already confused enough. Anyway, circuit input is the data used by the cryptographic circuit to perform computations within the proof. Values fed into the circuit to compute a solution or verify a statement. The witness is the data that proves the validity of the statement. So it can include the steps. The actual solution to the puzzle is the witness. Yeah. If the conditions of the contract are not met, there'll be no witness. Yeah, that's definitely true. Okay, so I was wrong. It's rather secret data that satisfies the statement being proved. This could be thought of as the solution to a problem or hidden information that the prover uses to demonstrate the validity of the statement. The solution itself, I mean, but it's got to be a correct solution. Is that what you're saying? Quite the contrary. You're saying that the witness is an input that satisfies the conditions. If the input does not satisfy the constraints, then it's not a witness. Yes, so I'm reading the question. In a zero knowledge proof, witness is the secret key, e.g. a password. Circuit input is the hash. I don't think that's quite correct, because the witness is the private data. It is that solution to the problem that you're trying to prove that you know the solution to. It's not directly shared, no, but nor is the input. The input is not shared with the verifier. It's basically the thing that I want to understand is the difference between the input and the witness, because they essentially sound like the same thing. I think I've got to keep reading. Noir is Rust based. Just seeing what Comrade Peter is saying. If something didn't happen, then no one witness it. So if the contract is invalid, then there'll be no information witness. True. So the witness is an input that satisfies the constraints. I'm going to be late. See if it says yes to that. If it doesn't, I'm just gonna have to go anyway. Yes, exactly. Okay, cool. We can go. So thank you so much. I'm gonna switch over back to just me. Thank you so much for watching this live stream. Sorry if it was a bit frustrating, but I had loads of fun. And thanks for all of the comments and everything. I hope you have a lovely weekend.